Welcome to Block 2. Here we're going to have a look at the current status of the climate and the environment, and we're going to refer to a document that was written by the IPCC. I imagine most of you have heard of the IPCC. They're the Intergovernmental Panel on Climate Change, and they are the United Nations body for assessing the science related to climate change. The panel was established in 1988 to provide policymakers with regular scientific updates on the current state of knowledge about climate change. The IPCC document that we will be referring to today is called Global Warming of 1.5 degrees C. You will find this, a link to this and a number of other related IPCC produced documents on the Moodle webpage. You'll see there on the screen that I have the description of what the document is. It's an IPCC special report on the impacts of global warming of 1.5 degrees above pre-industrial levels and related greenhouse gas emissions pathways. Now, this project or this report was developed in the context of strengthening the global response to the threat of climate change, sustainable development, and efforts to eradicate poverty. So sustainability and sustainable development were one of the reasons that this report was derived in the first place. So while there are many aspects to sustainable development, the effects of global warming on our climate and the consequent environmental impacts have a strong influence on many of these. Here we're going to look at some key data and predictions from the special report, which I just outlined for you, and it's based on the assessment of the available scientific, technical and socio-economic literature relevant to global warming of 1.5 degrees, and for a comparison between global warming of 1.5 degrees and 2 degrees above pre-industrial levels. So the focus of this overall report is the impacts of climate change on the 1 degree, which we're already in the midst of, and then the impact that it will have if it goes to 1.5 degrees or 2 degrees, because these are the two quite likely scenarios going forward, which this report explores. In the report, you'll hear terms like high confidence, medium confidence, low confidence, or rather you'll read those if you look at the report itself. And these levels of confidence are associated with each key finding, and they're reported using a calibrated IPCC language, which you can find more details of in the report. So rather than continually referring to levels of confidence for the purpose of this presentation, all of the statements that I will make will be of high confidence with some medium confidence statements. I will occasionally refer to confidence levels if it's appropriate. You can get the exact details and the level of confidence on each of the statements in the report itself, and you will find the link for this on the Moodle webpage. Just to outline that the underlying scientific basis of each key finding is indicated by references provided to chapter elements in the actual report itself, so you can look at those if you wish. So here we're going to look at a number of topics. We're going to look at rising temperatures. We're going to look at the risks, some of the risks associated with that, and also we're going to close on sort of mitigation and adaptation. I think we're all probably aware that global warming is a reality and has been happening for quite a while. Human activities are estimated to have caused approximately 1 degree of global warming above pre-industrial levels. The range for this that they found was likely between 0.8 and 1.2 degrees. These activities have resulted in the generation and emission into the atmosphere of various compounds and substances which have resulted in global warming. These are often referred to as greenhouse gases as they result in an increase in the global temperature. When these gases are the result of man-made activities, they are referred to as being anthropogenic. I just mention that because this is a word that is referred to quite frequently in the report, and it just refers to man-made. Global warming is likely to reach 1.5 degrees between 2030 and 2052 if it continues to increase at the current rate, and that's a very important thing, that if it continues to increase, and that is a high confidence prediction. Warming from anthropogenic emissions from the pre-industrial period to the present will persist for centuries to millennia, and will continue to cause further long-term changes in the climate system, such as sea level rise with the associated impacts. This is another high confidence prediction. But these emissions alone as they stand are unlikely to cause global warming of 1.5 degrees. Now that's a medium confidence prediction. Anthropogenic emissions, including greenhouse gases, aerosols, and their precursors, and there are a number of these different gases which we will be looking at in detail later on in the climate action section of the SDGs. These emissions up to present day are unlikely to cause further warming of more than half a degree over the next 2 to 3 decades, and that's a high confidence prediction, or on a century timescale. So what does this mean moving forward in terms of global warming? Scientists predict that if we reach and sustain net zero global anthropogenic CO2 emissions and decline net non-CO2 radiative forcing, we would halt anthropogenic global warming. So there's a few terms there I'd like to explain. Radiative forcing, you will come across this a number of times in this report, is a change in the energy flux in the atmosphere caused by natural or anthropogenic factors of climate change. And for the nerds among you, you might want to know it's measured in watts per square meter. In a nutshell, positive radiative forcing means the Earth receives more incoming energy from sunlight than it radiates back to space, which will result in warming. Conversely, negative radiative forcing means the Earth loses more energy to space than it receives, which would produce cooling. So any positive radiative forcing is going to increase the global temperature. Thus, when they talk about declining net non-CO2 radiative forcing, it means reducing the amount of radiative forcing caused by gases other than CO2, for instance, methane or nitrous oxide or halogenated gases, the other gases that are all considered greenhouse gases. So, if we do reach net zero global CO2 emissions and decline net non-CO2 radiative forcing, when would we see an impact on the global warming temperature? The report informs us that the maximum temperature reached would then be determined by cumulative net global anthropogenic CO2 emissions up to the time of net zero CO2 and the level of non-CO2 radiative forcing in the decades prior to the time that maximum temperature are reached. That's a medium confidence prediction. Basically, the report there is saying that the maximum temperature will be determined by the cumulative CO2 and non-CO2 forcing. But will this be enough to prevent long-term changes? On a longer timescale, sustained net negative global anthropogenic CO2 emissions and/or further reductions in non-CO2 radiative forcing may still be required to prevent further warming due to Earth system feedback and to reverse ocean acidification, and will be required to minimize sea level rise. So basically, in the longer term, we will continue to need net negative global CO2 emissions. So we will continue to need to have reduced CO2 emissions if we want to halt the increase in temperature as we go forward. In order to do that, in order to reduce our emissions going forward, we're going to have carbon sequestration or negative emissions, and that's going to be essential for this to happen. So what is carbon sequestration? Carbon sequestration is the action of chemically sequestering carbon. So carbon sequestration is the process of storing carbon in a carbon pool. In this case, it would need to be safely stored. By safely storing it in elements on the Earth, we then have the net effect of negative emissions because it has taken it out of the atmosphere.